Okay, this is the P4 paper from October 2023. It's question number 4, and this is a proof by contradiction question. We're trying to prove that for positive numbers, we'll come back to that in a second, but that for positive numbers, k plus 9 over k is greater than or equal to 6. So just a quick reminder about how we do proof by contradiction. If I'm trying to prove this thing here, what I start off is I assume the opposite of that. So I'm going to assume that that's less than 6. Hopefully that won't work. So I'll assume the opposite. I'll go through a mathematical process. And what I should do is get to a stage where I get a contradiction, something that doesn't work. As soon as I get that contradiction, I say, right, if I have that contradiction, then this assumption is wrong, which means that the original thing must be true. That's how we do all proof by contradictions. It'll make a little bit more sense when I actually do it with the particular example here. So we're saying proof by contradiction that k plus 9 over k is greater than or equal to 6. So I'm going to say, no, I'm going to assume the opposite. K plus 9 over k is less than 6, which I'm hoping isn't true because otherwise the proof won't work. So I'm going to assume that. If I assume that, and I'm going to try and solve this inequality now, what I want to try and do is get rid of that k on the bottom. Now, normally you can't multiply throughout by k. I'm going to multiply both sides by k. You would not be able to do that if we didn't know that k was positive. If k is positive, then it's okay to multiply by k on that side and by k on that side because we know it doesn't change the inequality. If k was a negative, the sign would need to change, but k isn't negative, so I'm okay to have that part. Make that into a quadratic inequality with 0, so minus 6k plus 9 less than 0. Excuse me, and then this is where your experience of these questions kicks in. That's not easy to see, but this is the only thing that I can do with this part here. I'm going to factorize this, and I'm looking for it to be, which I've got here, a perfect square. K minus 3 all squared being less than 0. Because once I see that that's a perfect square, that's impossible. K minus 3 squared, if it's a perfect square, can't be less than 0. So this is untrue. Therefore, my assumption is wrong. My assumption is false. I always say my assumption is false. And if my assumption's false, that k plus 9 over k is less than 6, then k plus 9 over k must be greater than or equal to 6. Those 3 dots mean therefore, therefore. Done. So followed the standard protocol for a proof by contradiction. So part 1 done. Show that the result in part A is not true for all real numbers. Well, we're going to show that it's not true for a negative, aren't we? So just pick a negative that it doesn't work for. I'm going to say assume k or let k equals minus 1. Check beforehand that it works for the value that you've chosen. But let k equals 9 minus 1, then k plus 9 over k will equal minus 1 plus 9 over minus 1, which will equal minus 1 minus 9, which equals minus 10 here. I've done the thing that I always tell my students not to do, write it all on one line there. But if it's minus 10, minus 10 is, what do I want it to be? Greater than or equal to 6. Minus 10 is not greater than or equal to 6. Therefore, not true for all real numbers. It's not true for negatives, basically, I think. It's only worth 1 mark for that part, so you don't need to spend ages and ages on it. Okay, so hopefully that will make sense to you.